Yeah, thank you everyone who's joining us this evening. I'm Zenaida. I'm a project architect at Ware Malcolm, and I've been the co-chair of the committee for about a year and a month now. This is our second meeting of the year. We're pretty happy to have everyone, and thank you, Megan and John, for being the presenters today.
Hi, everyone. I'm Robert Crawford, chair of the LA Building Performance and Regulations Group, along with Zenaida. And yeah, we're so pleased to have Megan and John join us. John's a colleague of mine up in the San Francisco office, although we haven't met in person yet. We're so pleased to have both of you join us. Megan and John worked together on a project, the DPR headquarters, which was a mass timber project. And I think they had a great time on that, learned a lot. And John's been working on some research and reaching out to all kinds of folks around the mass timber industry. And Megan's been a passionate advocate. And so they've kind of joined forces, and they're going to share some lessons learned and talk to us about some of what clients might be thinking about and what risks are in their head when we're talking about using this relatively new technology, though obviously pretty well established in other countries. So with that, please feel free to put any questions that come to your mind in the chat. And I think John's going to present first for about 20, 25 minutes, and then Megan will present next for the same amount of time, and we'll have at least 10 to 20 minutes for a discussion near the end. So without further ado, John, take it away.
All right. Let me warm this up for everybody. So hopefully everybody can see my screen.
Yep.
Hi, I'm John Spanier. Megan and from Holmes Structures and I are going to be presenting on the research and resources for implementing mass timber. It's so great to be here at presenting to the AIALA. I actually spent some time living in Santa Monica Canyon. I love LA. Had a great experience there. You have such a great community. As far as our learning objectives through this because I think that this is something the AIA likes to see, we are hoping to address some real life issues, understanding some hurdles to implementing mass timber on projects, exploring some risks associated with mass timber and discovering some ways to mitigate them, to gain some insights from lessons learned from previous mass timber projects, and hopefully provide you guys with some resources that are going to help you to get yourselves prepared for any new mass timber projects that are going to come along your way. So here we are. I'm John Spanier. I'm a project manager at the SmithGroup office in San Francisco. I've been there for about 4 years, and I've done a variety of projects in California: commercial, office, hotels, residential, et cetera. And important to this conversation is that I've been interested in sustainability and sustainability issues all my life. It's really been, the environment has been a real driver in how I've approached architecture, green building, and all sorts of forms. And I think that that's, you'll hopefully see some of that through this presentation. And right now I'm going to be presenting research that I've been doing over the last year or so about why clients are deciding not to use mass timber on recent projects. Megan, I'm going to give this to you a little bit. She's an associate principal at Holmes Structures in San Francisco, and wondering you might want to give a little bit of an intro for yourself.
Sure, yeah, thanks. Yeah, associate principal, I work out of our San Francisco office, but been doing a lot of work down in our LA office as well, and helping out on some projects up in Portland and Seattle that we have. Been luckily working with mass timber since 2015, and have almost been solely working on mass timber projects of late. I think we've been lucky enough to see a huge explosion in mass timber projects, and I guess having been a slightly earlier adopter in California, it's really pushed ourselves or put ourselves in a really good position. I have also a big passion for structural sustainability. So working more with mass timber has been something super exciting and how we can just reduce the embodied carbon of our structures. And yeah, excited to talk to you all today and go over some lessons learned from our recent projects.
Thank you, Megan. So here's the topic that I'm going to speak on today, and this is actually the title of my research paper, is why not mass timber? You know, it's a question both, I think, to be asked to understand what's going on in the market and to prepare for future projects. And also worth noting, at least on my section of the presentation, is that the slide format, it's really intended to be a resource for you guys to take with you and to use. And so we're going to be offering you a PDF of the presentation today. And there's going to be links and references and hopefully some key points to help you get ready for your next mass timber project. So why not mass timber? You know, and why this study? Well, one of the easiest questions is the climate, right? I found this slide from a recent green build presentation that SmithGroup did, and this is the simplest breakdown I've ever seen. You know, it's warming, it's us, we're sure it's bad, and we can fix it. Aligned with this is a recently coined Marshall effect that came out of the 2020 edition of the North American Mass Timber State of the Industry Report, which I have links to later in this paper. And this Marshall effect is described as being, if we could see the number of mass timber projects doubled every 2 years, then by 2034, the North American building industry will be carbon neutral, right? I mean, that's crazy. And so it's one of the big reasons, like, why don't we want mass timber to be, you know, a popular construction system? The big question is, why are we not building more mass timber projects? I've been asking myself this question for a really long time. You know, I decided that I just wanted to know. So I reached out to as many clients and industry professionals that would talk to me. And specifically, I was reaching out to people who had considered mass timber early on in a recent project, but ultimately didn't use it, right? So the point being to identify that decision gate early in a project and understand, like, why it didn't happen. The people that were willing to talk to me include a broad spectrum of people who are part of that decision process. You know, I was lucky enough to talk to a colleague at Harvest Properties, at Stanford University, at Trubeck Construction, at Bill Group Construction, at Tom Robinson and Lever Architecture, colleagues at SmithGroup and Arup, and really grilled them about, you know, what had happened recently about projects that hadn't proceeded with mass timber. The results were these, you know, and this is going to go over in terms of the risks and in terms of the identified advantages. And the main reasons that people saw as being true obstacles to mass timber are that cost and supply chain variability, the lack of data, both in terms of market value, market placement, user experience, building performance, all that kind of thing. Also, lack of team experience, primarily with general contractors and structural engineers, unfortunately. Another one was the risks to approvals and permitting, and then, you know, the ongoing struggle to get mass timber to be codified for use as a seismic or lateral system, right? And I think if you put your client lens on, the hat on, what we're just looking at is predictability. as far as advantages that were identified, everybody I asked if they wanted to do a mass timber project, 100% of them said yes. And there really is a sense of the intrinsic value that mass timber brings to a project. You know, there's an assumption of a market and asset value. There's an assumption of quality. There's an assumption of a desirable look and feel. There's actually quantifiable construction efficiencies, and there are real carbon advantages. You know, some of these we have information on, some of them we don't. Interestingly enough, I've been lucky enough to be a footnote in an upcoming research paper that Woodworks and the Wood Products Council has done for ClimateWorks. It's hopefully coming soon. We have colleagues from the Woodworks group, Mike Romanowski and Jennifer Cover, also on this call, hopefully be available to answer some questions. And they did the same thing. They surveyed 84 different projects that had considered using mass timber and ultimately didn't do it. Theirs is way more in depth, tracked these projects for a longer period of time, but it's also validating to see that they had, what I've seen so far has been very similar to the results that I got. Then one thing I want to stress here is that if there's one takeaway that you guys have after listening to this talk, is that we absolutely need to give our clients more predictability. That's the whole thing. I mean, if you think about it, you're a client, you're trying to figure out, well, is my project going to be successful? Is my project going to make money? They need to have understandable information and reliability to be confident in making the decision to go through and take on mass timber. So I'm going to go through these one by one, both the risks and the advantages, and kind of give you a sense of like some resources that I think are going to help you prepare for any upcoming future mass timber project that you want to take on. So cost and supply chain, you know, cost is all over the map. One of the problems with mass timber is that not only does the cost fluctuate, but it's different from region to region. One of the people I spoke with at Trueback, they have offices in both San Francisco and Oregon. Oregon, it's much cheaper, you know, for obvious reasons. There's a lot of timber there, and the mass timber products are being locally produced. California, we don't have that advantage yet. But it's also true. They're building new plants in Arkansas and in the East Coast, and it's totally different. So what you got to do is you really have to get into your locale. One of the things that I've gotten from both general contractors and from fabricators is that you got to look at the annual cost data in your region, right? They're taking yearly average costs for mass timber to determine, at least for estimating purposes, like what the cost could potentially be. You know, that's a good place to start. You also need to watch the lumber market. Discovered recently on a project that in September or November of last year, lumber prices spiked. You know, everybody's laid off because of COVID, production facilities are down, everybody starts designing and wanting to do mass timber. There's nobody to provide it. So what does it do? The wood gets really expensive. So you have to plan. This, you know, there are ups and downs all the time, but you are kind of playing a commodity game. So you gotta plan when you're going to purchase the material, and it might be earlier than you think in order to get the best price. Correlated to this is you need to know your regional suppliers. They are the people in the know, right? They know, you know, the issues of delivery, a lot of codes, a lot of plan check stuff, numbers, all sorts of information. They are your ally in this stuff. And you want to kind of introduce yourselves, and your region probably has a few that are going to be your most active suppliers. Again, to the regional activity, every place is a little bit different. And what we have here are links to a couple of nice tools, is Mass Timber Map and the Woodworks Innovation Network project map. This right here is an example of the Woodworks one. These tools allow you to see what's going on in terms of the world of mass timber. You can put in your locale. They give you information on projects. They give you information on those projects in terms of project teams. And you can almost develop your own partnering by understanding the people that are working on these projects in these regions.
John, to
yes.
ask one quick question there on cost, would you characterize that fluctuation between regions as both a sort of chicken and egg problem where the codes haven't changed in a certain area yet, and thus no one has decided to invest in trying to create a sustainably forested, where it could exist, like we see some in the Pacific Northwest, but there's not one in California yet, like you mentioned.
Yeah,
and
it's interesting. I think, it's a lot of our wood is actually coming out of the South these days. And you guys correct me if I'm wrong, Mike. There are places that are developing. I don't think it's the timber supply itself. It's really fabrication. And I think people are hedging their bets. Like, it's been really up and down in terms of the demand. I think as soon as we hit the market share and people are really interested and it starts to develop, I think that's really going to change. So I think it's less about having the wood available than it is, I think, really about the mechanics of it all.
So if we
yeah, go ahead.
Were, as a simple example, tomorrow to try and build something in Los Angeles, to get that done, we're not able to keep our embodied carbon low, which is one of the main reasons to use it, because we're having to, even if it were right near us, ship it out and ship it back, which is,
I've heard a discussion about that particular issue, and it actually, because of the amount of both carbon sequestration in the wood and the lower production of carbon in the processes for doing mass timber versus steel or concrete, it actually still is not as impactful as you might think to bring this stuff in from, Europe even, right? And that's still happening on a lot of projects.
Ideal to have it as close as possible.
Yes, and that's
for a number of reasons, and that probably still impacts the cost if you're having.
It's going to impact the cost. It's going to impact the schedule. It's going to, ease of deliverability, all sorts of things that are. And we're hopefully going to see it. Companies like Google were exploring, just doing their own mass timber factory in California. I don't know what happened to that. I heard little inklings of it at the last mass timber conference a couple of years ago. I think it's probably in the works, but I think we're gonna have to wait and see for mass timber to get a little bit more traction, honestly. At least
I'll add real quick.
Yeah.
Yeah, John. Yeah, to your point, I think transportation is really a relatively minimal impact if you would consider that alternative building out of steel and concrete. So very similar to the point John made. And I think you're also saving on seismic weight of your structure. So lighter foundations, less lateral systems also needs to be accounted for. And one other thing I'll mention, yeah, we're starting to see a lot of European suppliers really interested in the U.S. market. And right now, buying lumber from Europe is the same price or cheaper than getting it from North America. And there's definitely some big suppliers looking at opening plants in the U.S. and supplying it with North American lumber. Yeah, so it's all gonna, there's just gonna be a bigger play of players in the mass timber market very soon, and it's going to definitely drive down costs.
Nice. I imagine the market fluctuation in areas that are more established, like Europe, is probably quite a bit more even.
Yep.
So we just need to get going.
Hey, John, you stopped sharing.
Yeah, I lost my internet there for a second. I apologize.
No worries.
One more time. All right. So can you hear me still?
Yep.
Okay. So I missed a little bit what you were saying last, Megan. I'll just go ahead and keep
okay. Yeah.
Okay. Data. So data, unfortunately, is one of these things that is harder to address. This stuff's changing. We don't have as much really solid information about, ROIs for clients and
Oh no, John's internet's going in and out. I am happy to jump in and switch, and then we can get back to John if you think that's the easiest.
Probably
Or we can
sounds
wait
good.
another minute.
Yeah.
Okay.
Jennifer had a comment. Woodwork is working on an LCA case study for Plate 15, a building in Colorado, and even with the CLT material being shipped from Quebec, the mass timber GWP was the 70s to 76% reduction compared to steel and concrete. Do you want to
Yeah.
add to that, Jennifer?
Yeah, so that report, hopefully we're just finishing it up right now and happy to share. But again, the transportation, to Megan's point, is actually a lot lower than you would think when you look at the overall impact. To me, when we're looking at this study, what was really incredible was that the impact from just the concrete topping, you look at the chart, it's like this much from the concrete, and then you barely see a sliver of wood in terms of contribution towards the carbon impact. So
Oh, wow.
It'll be a great study. It should be out shortly here, but I just wanted to address it real quick because the question regarding transportation.
Yeah, thank you for doing that.
Yeah, we've been seeing a lot of similar things in our studies. One thing that I will just mention is, I guess with wood, a lot of the biogenic carbon aspects of wood and the sequestration and how that should be accounted for is definitely something, at least among the structural engineering profession, that we don't yet have a good consensus on, and something that we're working on actually within one of the committees I'm involved in, and so should hopefully have a bit more guidance out there on that, because it's definitely a hot topic in our profession right now. Hey, John, you're back now.
Hi, I'm back. I apologize. I don't know what's going on, but hopefully that was the last of it. Anyways, some information. The recent State of the Industry report for North America, mass timber, great resource. A ton of information in there. I can't recommend it enough. Talk to your regional suppliers. Talk with your peers. There's all sorts of stuff. I can talk with Megan. I can talk with, my friend Thomas Robinson or whoever, like working on these projects. And there's all sorts of shared information that we can glean from each other. And, to that, the mass timber community itself is this great resources just alone. It's very open source and super cooperative. And Woodworks is part of that, and the Mass Timber Conference is coming up, and I'd highly recommend a lot of people that if you're interested in mass timber, that's a great place to go. The other thing is, insurance. A lot of people don't talk about insurance, but that's a huge issue. And Woodworks just came out with this new guide for insurance underwriters on their website. The link's here, and then they also have a whole bunch of solution papers that talk about all sorts of things from fire to you name it. Next thing, project teams. Project teams is like one of the biggest things that we as architects and engineers can take on, right? By and large, one of the things that in the study that came across is just lack of both having disciplines being at the same level to share and really effectively cooperate, GCs who are, risk averse, who are like overpricing this stuff, structural engineers, unfortunately, who are like also risk averse and like overbuilding things. Like we had a SmithGroup project that the structural engineer did a 6 foot by 6 foot column, in the middle of the, throughout the project. It was just ridiculous, right? So the key is not everybody's going to want to do a mass timber project. So you need to start talking to people that you would want to partner with now, right? And start with your GCs and your structural engineers. They're going to be the key players with your architects who are really going to bring this thing together. Also be comprehensive with your teams. A lot of these partners can be overlooked, like fire sprinklers, for example, or acoustics, like that really can have a very fundamental influence on your project, because don't forget, all this stuff has to be in BIM. It's all super coordinated. It's all prefabricated. Everything's pre-drilled. Everything's ready to be assembled. You can't have your MEP design build folks that are just like, oh yeah, here's a line drawing. I'll figure it out when we get in the field. Just doesn't work, right? So everybody's got to be on the same page. That said, if you have that in place, you also might want to consider looking at how you're going to divide your fees and understand your phasing. You know, I say that because, and Megan's going to get into this, there's a lot of front-loaded effort on this stuff, right? You got to get this stuff dialed in schematic design even, like you're really modeling this stuff and understanding your grids, and you're understanding, you know, you have your supplier on board, and you're really having very robust conversations about getting this stuff built. Scheduling, you got to keep your eye on scheduling. It's not just bringing, you know, how long it's going to take, but it's, you really have to work out your sequencing in particular. You also need to deal with, you know, seasonal stuff. You know, water can be an issue. It's not the end of the world. Things get wet, but it is nice if you can schedule your stuff so that if you have stuff laid down, it's not getting wet, or you're minimizing any kind of water intrusion. There's also a great planning tool, again, Woodworks, doing a lot of stuff. The optimization checklist, links here, runs through all the phases, things you want to look at, things you want to identify, and ways you can optimize your delivery. Rules and permitting. Why is this a problem? Because clients don't want to risk the schedule of their projects, right? The faster they get it to market, the better chance it's going to be financially successful. So you got to know your code. You know, there's going to be, here in this case, California, we have the advantage. It's like just adopted pretty early the new IBCs for 2021, the new categories of type 4. I think that only goes into effect really in July of this year, but it's going to be super important for you guys. You also need to talk to those people that you would bring the project to. Everybody's different. Every city's different. It's really advantageous to have them as part of your team. And that includes the building officials and the fire officials. You want to meet with them early. You want to understand if mass timber is a non-starter for them, because, you know, why waste your time? And that's going to save, you know, stress on your client. You might want to understand if there's a third-party plan check, because that's another kind of can of worms. That happens to us up here in the Bay Area a lot. So you might want to take a look at that. Seismic performance. This is one that came up over and over again in the study, and it's really because it's just not codified yet. If you want to use the lateral system, the mass timber lateral system, you have to do your alternate means and methods request. You know, so that's lengthy, complicated, peer review, expensive. Chances are you're going to do a hybrid structure, right? So you got to understand what that means. So you're going to either use steel, or you're going to use concrete, right? Those have different advantages, disadvantages. There are complexities. It's, you know, there's going to be a little bit extra cost, there's going to be a little extra coordination. There's going to be different construction tolerances you have to keep in mind. So your joints, any connection points are really critical. And different construction timelines, particularly if you're going to do a cast in place concrete, it's got to dry, right? So you got to figure out how that's going to go up while your wood system components are going to go up much quicker. And they're also water averse, so you don't want to have them up against wet concrete. Client advantages. There are a lot of great client advantages. You know, the value, perceived quality, the look, the feel, construction efficiencies, carbon advantages. The mass timber is a great place. Report is a great place to look at for starting to flesh out the idea of the ownership of a mass timber building. You know, they go through some of the things you want to keep in mind, some of the risks. There's still not a lot of data about this. Hopefully this is going to keep growing. Quality, right? How do you point out quality? One of the things that came up, it's like hard for clients to see projects, to experience projects. So it's, unless there's stuff in your region that you can take people to visit, you got to convince them and give them metrics around other successful projects. These are three that I picked kind of not exactly at random, but they're definitely projects that have positioned themselves at the high end of the market, right? The Radiator in Portland, really early 2014, Kaiser and Path. They were leased out office space before the thing even finished construction. T3 also positioned itself very high market, office and retail. I believe it's been very successful. The Ascent, now under construction right now, going to be one of these big, tall buildings. They're getting good investment. They're definitely leading with this being a high-end project, residential, 250 some residential units. That's one to keep your eye on. I think we're going to get a lot of good metrics out of that one. Biophilia. These resources don't necessarily talk about mass timber per se, but they do discuss human responses to wood. These two examples are the most recent being this one out of Australia, workplaces, wellness and wood equals productivity, really kind of codified a lot of the upside that you can use as metrics and reference to your clients about productivity, satisfaction of your workplace, all these other kinds of things. And it's really quantifiable, and that translates to dollars for company owners, and therefore might incentivize people to spend a little bit more money on renting those spaces. Wood is a restorative material in healthcare, 2015, a little bit older, but also documents out of Canada, positive effects of wood in a healing environment. Big one, construction efficiencies. This is really where mass timber shines and starts to have a lot of great information. Again, going to the optimization checklist, please read through this. It's really super informative. Understand your structural grid. The difference between mass timber and steel and concrete, completely different thing. It's a has completely different advantages and strategies for getting an efficient structure. And you can do it in ways where you can create really open areas. Holmes Structures has this awesome timber builder optimizer thing. I think Megan's going to show you in a minute. FastApp has this mass timber bait calculator. It's a free tool online. Take a look at all these things. You really have to explore and have a great structural engineer on board who understands these nuances. And be repetitive. If you want to save money on these projects, you can still have a beautiful project and be intelligent about prefabrication. You're going to save money by having the same size shapes of components as much as possible. It's going to make it faster to go together. It's going to be faster to produce. Significant cost savings can be realized. Carbon calculator. At the end of the day, a number of people said carbon was one of the main reasons that they wanted to use mass timber. And that's great. One of the things that you can do, there are a couple of carbon calculators. This one's the Woodworks one. The link here, you just have to register, and it'll let you put in all of your wood components, and it'll just give you very specific metrics about your own project. It's a great tool to track the carbon impacts of a mass timber project. This pretty much comes to the end of my part of the presentation. The call to action to you guys: if you're an advocate of mass timber projects, you have to start with your client, right? This whole thing that I'm trying to get you today is you have to put your client hat on and understand where they feel comfortable, where they feel uncomfortable, and really come at this thing with a tool of kits, a good team, and a lot of understanding about what's going on in the current marketplace. Hopefully we've given you a little bit to look at and start to develop your understanding about mass timber with this stuff. Yeah, this is my contact information. Feel free to contact me. I'd love to talk to more people, get more people part of the research. Also have some contacts for folks in LA. If you want to reach out to them, they're mass timber advocates in our SmithGroup LA office, and Mike Romanowski, who is your local rep for the Woodworks group. Thank you for listening.
Thank you, Mike. Just an update on the chat, you guys. Someone was asking about if we could share all of those links on your presentation, but I saw that Megan said that we can share a PDF. So
yes, so we're going to give you a PDF after this, and we can follow up with everybody, and all those should be live, and they should be able to utilize them.
yeah, we can probably get everyone's email for those who register, for everyone who registered. I think we have that. And yeah, we'll be sharing the PDF so you can have that information. Jennifer is also sharing some of the Woodworks publications. So maybe afterwards, Jennifer, if you can send us an email so that we can redistribute all of the links.
Yeah, I'd be happy to. Thanks.
Great. And sorry about the background noise. We're having a lot of fun here, as you can hear.
That's great. Sounds like my house.
Okay, go ahead,
All right,
Megan.
sorry, let me hide you guys. I only have one screen today, so it's a little, get that out of the way. All right, so yes, thank you guys for having me today. Really excited to talk to you about some of our lessons learned from recent mass timber projects. And I think a lot of what you'll hear me talk about today really complements a lot of stuff that you just heard. So yeah, just trying to put some realistic nature to what John's been talking about. So I broke out the beginning of the presentation kind of in lessons learned and trying to focus on some three main ones that we had, and then we'll end on just some project examples. So my first lesson learned, and John just kind of touched on this, is grid and manufacturer capabilities. I think one thing that hasn't been touched on yet is that every mass timber manufacturer has a different size dimension of mass timber panel that they want to produce and is the most efficient for them. So really understanding that is helpful before setting out your grid. Most manufacturers' presses are up to about 40 feet long. Some can go longer, but trying to understand that when you're laying out grid, as well as if you're getting lumber from Europe, you're usually governed by your typical shipping container constraints. And so thinking about that and how you lay things out is really important. When we think about grid, I'm going to talk to you about just some of the main options that we see in our projects. And so this is kind of focusing on that commercial office grid that really wants to be that 30 by 30 grid. And so being able to achieve that with mass timber, you're usually going to be introducing beams and girders. So having beamed elements in two directions. There's some really fun things you can do with how you orient your beams, whether you kind of push them down a bit to allow for services to run. And we'll definitely talk about MEP integration in a few slides here, but lots of play there. And you can also look at integrating in different types of beams, so it doesn't need to be wood. You could also introduce in concrete or steel. The next grid kind of looks at if you're really trying to minimize the volume of our lumber. So looking at a much shorter span for that CLT, more in that 15-foot range is really kind of the sweet spot of where you'll get a smaller ply thickness panel and still getting a decent span, but looking at your beam spanning that 30 foot or more. And again, also seeing ways that you can integrate steel or even precast concrete as elements to kind of really span further if that's desired. And then again, looking at how you can orient your beams in vertical space. You can definitely play around with a lot of MEP integration in doing that. The other grid that really leverages, I guess, CLT's two-way spanning action is looking at a point supported option. So basically beamless. And so the panel is supported by just columns. And as you can probably guess, you're going to be limited on your column grid to how wide of a panel you can get. So typical panels are about 10 foot wide, but again, every manufacturer has a slightly different sweet spot for what size panel that they want to manufacture. But looking at a much more tighter grid of columns in this type of option, as you're seeing, this really lends itself well to residential applications, but we also are working on one that's in a commercial application that is in LA. Another kind of take on point supported option is a proprietary system called Delta Beam. And so it's a inverted kind of steel system that you cast into concrete. And so it does allow you to span a bit further while still kind of having no or very minimal quote unquote beams in your on your soffit. Again, also in construction on a couple of these systems, but more up in our Portland projects. So in addition to kind of grid, another kind of take on that is also podium. So a lot of our mass timber projects are looking at sitting on top of podiums. And so also trying to think about how you handle your transferring out of your mass timber columns at your concrete podium is also kind of going to be key in how you lay out your building, and things that should be thought about really early on in the project and should incorporate your structural engineer in those discussions. The next kind of lesson learned deals with integration and a bunch of different types of integration. So first up is that MEP integration. So this is something that we've definitely seen as key to making any mass timber project kind of stick. So if you can integrate your MEP into your floor system, you're going to have a much more likelihood of keeping the mass timber in your project. And so this is just some options of how you can do that, but there's probably many more out there, and we've pretty much implemented, I think, almost all of these on our projects. And so every mass timber project is different, and every thing just every project can come up with its own unique solution. Another thing with MEP integration that we've been seeing with our projects is that integration wants to happen a lot sooner in the design process. So even if you're, typical design build type scenario, really wanting to know where all these MEP penetrations want to go is going to be really critical, and something that really needs to shift in how we design these buildings to really make it successful. And we're also seeing in mass timber development, like really a push to how do you integrate a lot of these services even off-site and get them built in bigger pieces, so that when you're coming onto the construction sites, things are being just lifted into place. And so really trying to leverage the pre-manufactured nature of mass timber. So just some pictures of this in construction and how that's been able to work. So the left two pictures are showing kind of that gapped CLT option. And so you're basically just leaving a gap between your CLT panels and just spanning either conventional plywood over that, or even concrete in that space. And that allows you to just run some small services within that cavity. And the picture on the right is looking at embedding all the conduit into your concrete topping slab. Is just another option. One that might not stick around forever, as there is a big trend in mass timber to get the concrete out of the structure, superstructure at least. But anyway, it's another very viable option.
Again, I was curious, just approximately how many of the projects you're working on right now are design build or various different alternative deliveries?
I think all of them are pretty much, doing an integrated delivery approach. Only a couple are really design build in that aspect. So another type of integration is really project teams. So, I think John touched on this earlier. A successful project is also going to require the right team. And we've had some projects that just kind of died because you didn't have the right contractor on board or just the right team in general. So really trying to find that contractor, supplier, architect, and structural engineer that is the right fit for your project is going to be really key. Another kind of take on team integration, just as a great example of a project that I'll show you a bit more of in a few minutes, is just looking at just this typical beam to column connection that we have in one of our projects that was going to be replicated like millions of times. And looking at that first sketch when we were sitting down with the architect and how the beam column connection needed to be, we needed to put the column into bearing because the loads were too high from the beam to just attach it to the face. And so that was kind of that first conceptual sketch with like that bearing plate that would sit on the column and transfer the loads that way. And then, getting some further design team refinement by the architect in that they wanted that upper column to sit a little bit up above the top of the concrete topping slab. And then talking with the contractor about how that little HSS stub, how are they going to actually build that and get those columns to site. And so introducing like an upper HSS stub and a lower one so that they could be basically nested together when they came into place. And then kind of lastly, we got some manufacturer input. So noting that, the manufacturer's capabilities and how deep of a notch into that column that they could actually get with their CNC machine. And so we had to also change up how this was detailed based on their input. And I think another big thing is also kind of who owns what in this type of scenario. So a lot of our projects have been hybrid systems, so not just full mass timber, but having some type of steel or concrete gravity system. And we definitely had to pay a lot of attention in some of these detailing and had to redetail some things once we talked about who was going to be supplying what portions of steel in this case, for example. I think this is the last type of integration that I'll talk about, is really just that structure fire integration and how important and critical that's been. And it's been something that's been making us, I think, so successful in our mass timber projects, is that we do have Holmes Fire, so fire engineers in all of our offices. And we've been working with them a lot jointly on these mass timber projects, because, you know, that integration of structure fire when we're trying to, you know, keep the mass timber exposed as much as we can is really critical. And these are just some examples of how we were able to use their expertise in doing some fire analyses on some typical connections that we had in a project, so that we wouldn't have to introduce any fire rating. And then just some other examples of just even some fire testing that can be done, and that we've been a part of on some of our projects as well, just to really study some of these unique and atypical connections, but also just given that, you know, the research hasn't necessarily caught up to how quickly the design world is pushing these projects. And yeah, it's just anyway, exciting time. And then this last kind of lessons learned that we'll talk about is just, I guess, what I termed engineering considerations. So lateral systems. So John mentioned this earlier. What we're seeing a lot in our projects are really hybrid lateral systems. So basically what that means is sticking with a conventional either plywood shear wall, concrete shear wall, or steel braced frame or moment frame. Has been what we've been mainly seeing, just because CLT isn't strictly codified yet, and would have to go through an AMMR process to get approved. You are going to be limited in the height of the plywood shear walls, but it's definitely still a viable option in some of your low-rise buildings. But at that point, if you're building such a low-rise building, you know, we've definitely gotten the question, does mass timber even make sense or pencil out from a cost standpoint? But anyway, yeah, so just seeing a bunch of different stuff with the lateral systems, but I do think we'll start to see more and more mass timber shear walls coming online. There is going to be a codified approval for certain mass timber shear walls, but the kind of aspect ratio that the shear walls will need to be is not super applicable. So I honestly don't see that super taking off once that does become codified. But yeah, I guess I see us sticking around with some of these hybrid systems for a bit longer, and then utilizing mass timber shear walls if your project can afford that AMMR approach. So another kind of topic to touch on when looking at these mass timber buildings and how we're now trying to push spans of mass timber a bit further is, and this is one of our lab buildings up in Portland, where you know, the vibration was a really big concern for the project, and it had some pretty strict goals. So, you know, ensuring that your engineering team can run some vibration analyses for you on your project is going to be critical, you know, to the success of these projects. What John had mentioned, and sorry, I can't get this little banner to go away, was just given how much mass timber we've been doing, we built an in-house kind of timber optimizer tool that allows you to put in a certain amount of inputs, whether it's you know, grid, number of stories, fire rating required, and it kind of has a bunch of data from pretty much all the main CLT suppliers or mass timber suppliers. Is not just CLT, because we have some MPP and others in here as well, and it really spits out just very quickly you know, what the most optimum bay sizes are and grids based on, you know, wood volume or even cost. So we do have some cost data in there, but I would definitely say woodworks are probably having the most accurate information on that. But yeah, just something that we quickly tried to create and can use on our projects and talk with clients about, just to really quickly iterate between the different options. And anyway, it's just been a helpful tool that we've been using on a lot of our projects. And this kind of last slide is really just really hinting at is that, you know, what we've been seeing with these projects is that there's no one size fits all. So no one solution that works. And so we've been, you know, being able to, what's been fun from a structural engineering perspective is being able to get really creative with how we're using this system. So anywhere from introducing BRBs in that upper left-hand corner at the ends of a CLT shear wall to help with the ductility of that system and get that built and codify, or get that built and yes, through the permitting jurisdiction, or introducing precast concrete or steel beams in your project so that it can achieve the spans and the aesthetic and the construction schedule that was desired to, you know, just looking at the delta beam system that I mentioned earlier, or even just getting into doing some testing of different connections has just been all different techniques that we've been able to employ on these projects. So now I'm going to talk about some of our projects. It was hard to pick from all of the ones that we've got going, but I'll kind of talk to you about two that are basically done and completed, and then two that are in for permit and about to get constructed as we speak. So first up is just an example of how we were able to use mass timber as a diaphragm. So the structural diaphragm that transfers all the lateral loads out to your seismic elements. So this was for the Brentwood Public Library. This project was built back in 2015, 2016. So it's been open for a few years now. One thing that was unique with this project is that it was one of the first mass timber buildings in California. And we were working with Fog Studio Architects, which they designed actually the first mass timber building in California, which was just a small project in the Bay Area. But anyway, it was fun to work with them, and the fact that, you know, I was excited about mass timber and Holmes was, but was just like, you know, pitching in on our projects. And for once, you know, we didn't have to explain to the architect what mass timber was. Another unique thing is that this was with a contractor that has never used mass timber before, but they were super on board with learning something new, and yeah, definitely was excited about that. And I think, you know, might not necessarily hear that from all of your contractors that you work with. But the main system for this was CLT for the floors and roof, supported by steel beams with steel moment frames. Oops, sorry, wrong way. Something that I love about these photos is that they weren't taken on a lunch break. And so it just really speaks to the nature of just how small the crew that's required to kind of construct these mass timber buildings. You can see here from the photos, at least on the left, that the contractor decided to erect the full steel two-story structure at once, and then kind of install the panels. So it definitely took a little bit longer to install the level 2 panels because they had to navigate through the roof steel and those moment frame braces that you can kind of see there. But the roof panels and the panel installation went very fast, and we almost actually missed getting photos of some of these last panels going into place. Just the contractor, since he had never used it before, yeah, just had allotted for a lot more time in his schedule than it actually took. Just some pictures of what we were able to do within the diaphragm. So the two pictures on the left are showing the level 2 structure. So we did have a small concrete topping slab, just mainly to handle the stack loading, given that it was a library, but able to run some small conduits in there. And then since we were using the mass timber as a diaphragm, you can see that we had kind of put a plywood spline to connect the panels on their kind of longitudinal joints. And so that ties that diaphragm together and is able to transfer loads out to your lateral elements. So just some other pictures in construction. The picture on the left is really just showing or utilizing the two-way spanning action of cross-laminated timber. And so you're able to achieve some pretty cool double cantilevers with that system, and then even just some nice and decent cantilevers in the main direction of the span. And so, yeah, looking at kind of the building and after it was built, so in its final condition. So again, being able to see some mass timber exposed on the exterior, you obviously need to be careful with how you're detailing that whole detail for waterproofing, but it is achievable. And yeah, just a really great example of a small project that was just a super success story. This next project that I'll talk about quickly is just an example of a big mass timber corporate campus that almost done in construction. It's literally supposed to open any day now. I think it'll probably be another month or so, but it will be the largest North American mass timber building constructed. I know there's already other larger projects in design, but we will kind of hold that title, I guess, for a little bit. But a couple interesting things about this project is, you know, when we originally looking at the massing of this project, we were looking at you know, the larger, like 5-6 story, I guess I should say taller, like 5 or 6 story office building, or we kind of played around with this scheme of what we called courtyards. And so this more low rise, more residential feel vibe to it with these large contiguous floor plates. And that's what eventually won out. And, you know, wood plays itself really well to that. And given the fact that there were kind of on this campus 5 existing precast concrete tilt-up buildings, the owner didn't want to just go in and bulldoze all of the buildings, and so they kept kind of 2 of them, which are kind of shown in those L-shaped grayish buildings in the rendering, and then just kind of infilled in with this primarily 2-story low-rise mass timber construction. So it was approximately 645,000 square feet of commercial office space with equally large concrete parking structure. It was permitted through the mall provision, so we were able to keep all of the mass timber exposed. And the main gravity system and lateral system was composite, so it's a composite concrete and CLT slab. So we are relying on the concrete slab here to work with the mass timber so it can span further, but that's supported on steel beams and glue lam columns. And our lateral system here are concrete shear walls. And so I know John mentioned on this earlier, but tolerance was a big discussion on this project. So as you can imagine, having concrete shear walls, steel and wood was definitely a lot of fun discussions that we had with the contractor. Your mass timber is going to be pretty much, you know, delivered to the exact dimensions that you specified, whereas, you know, concrete tolerance can be up to an inch or more on your project. So anyway, just building some of that into your detailing was definitely key. For this building, just given how large it was, the contractor really pushed to build a mock-up structure. So this thing was pretty enormous. It's like 4 times the size of my apartment in San Francisco, but definitely money well spent. And so they wanted to just look at every single different condition that we had in the building. And they also dumped a fire hose on the structure before any of the roofing and stuff was put on, because the contractor was convinced that this building was going to get dumped on in construction, and they were rightfully so very concerned, because it did get rained on a lot when these panels were going up in end of 2018, early 2019. So if any of you remember, it was a very wet winter in the Bay Area, and so you can see some of that water staining on the mass timber there, and so the contractor mocked up just a bunch of different options for waterproofing. And also how they could mitigate it if they, you know, when the inevitable stain did show up, how they could fix that. And so anyway, definitely money well spent, but I know not every project can afford that type of thing, nor should they. So just some photos of some of the early panels going in. So the contractor had kind of decided to build this building like a steel building. So they erected the glue lam columns first, and you can see those came out with all their steel connectors installed. They installed the beams and then lifted the mass timber into place. And again, from this picture, you're seeing on the left all the pre-cut, the pre-CNC cut holes in your panels. And so again, the main reason why you really want to push that MEP integration really early on in design, so that those things can get incorporated. We had like I was saying, a composite CLT slab that also incorporated a lot of conduit and radiant tubing. That picture in the middle is kind of showing, yes, you can cut holes into the CLT after the fact, but it's definitely very labor intensive, and it just doesn't look as good and as clean as a CNC cut hole. And then, yeah, just some photos in construction. And yeah, just some more. We'll just kind of flip through these. These were just taken recently. As I said, the building is kind of slated to open very soon, but just a really clean aesthetic. And I think spending a lot of time on the fundamental parts of the building really helped us, yeah, just have a really successful mass timber installation. And then just real quickly, because I know we're running close on time, wanted to touch on just 2 other projects that are actually about to be constructed. So this one is in Marina del Rey. It just completed its permit and is about to be constructed. The construction did get a little halted because of COVID, but it was permitted through LADBS, and I think it's probably one of the first. And we were able to work with that jurisdiction, which, as you all know, is one of the toughest in the country, to be able to use the mass timber as a diaphragm. So that's technically not codified yet, but it will be in the upcoming NDS. But anyway, we were able to walk the authority through that whole process and was able to get that permitted. So it was very exciting for us, and we're really excited to get construction started. So again, another hybrid system. So seeing, the CLT supported by steel girders as well as glulam beams and steel columns, and that integrates really well with the lateral system of the buckling restraint brace range. And then this last example I just wanted to touch on was actually a small example of where we were able to get gravity and lateral in a building. So this is a public housing project of ours out in Sacramento. That is, we just got our plan check comments back for this. Yeah, it's just one of the first projects in Sacramento using mass timber. It is 5 stories, so it was able to utilize both plywood shear walls and mass timber shear walls. And we were able to do that without an AMMR, but had to design the CLT shear walls that were only located at level 1 of this building and are exposed, but just had to take a pretty big hit on the seismic ductility factor that we used to design it. But anyway, just another successful example of being able to get that mass timber into the project. And yeah, so with that, I think John and I really just wanted to chat with you more and answer any of your questions. Yeah, maybe I'll stop sharing and we can see your faces.
We circle back to the chat, Megan and John. Alexandra had a question about when can we use Holmes Timber Building Optimizer? That tool is awesome.
Thank you. Well, you can definitely shoot me an email. I'd be happy to talk with you. We haven't yet released that. I know a lot of people have been releasing a lot of their kind of built tools for the public. Yeah. So I don't know if we're kind of actually focused on trying to get more options optimized. So not just post and beam, but some other options as well for mass timber. I think we're focusing on that before we kind of would consider getting that released. But anyway, I'd be happy to kind of show you it and kind of answer any questions you have for your projects.
John, it looks like you had answered a question about recommendation for roof deck application. Do you want to expand on that?
Well, I'm not sure if I totally understand the question, but it sounds like there's an interest of having maybe an occupied roof on top of like a CLT panel roof. If that's the case, what I've seen in the past is like you got to be careful about where your moisture ends up is in relation to the wood roofing. So you might do a CLT, an applied membrane, then some kind of protection. It kind of really depends also on your, how you're doing your insulation. You could do a cement, you could do a PVC, and then bison pedestals on top of that. I think there's a lot of potential options that you would have for an assembly. I think it would really just depend on the particulars of what you're using and where you are.
And Dave had a question about what is the cladding on the Marina del Rey project? Do you know, Megan, the cladding, the exterior?
I can ask.
That vertical looking kind of like batten, like it had a little bit of batten look to it. Oh.
I will get you an answer in a sec.
That looks amazing. It looked amazing, whatever it was.
Yeah, and to answer the question that came up earlier, if the slide decks are going to be made available, yes. So we are going to provide the AIA the PDFs of all this stuff, and it's intended to be a resource tool for you guys to have available to you. So yeah, we're fully intended to do that. I'll reach out. Make sure that they have your email address. I think we have it through your ticket. So we should
I
be
don't know
reaching out
about
to you.
asking a question right here, but do you have to have
Please.
pre-qualified contractors to do this work? In other words, do they have to go through any kind of training or any kind of quality assurance or control at all?
I mean, if it were up to me, I would ask them to do some kind of training.
Okay.
It seems like there's a point of debate about who installs the CLT or the assembles the mass timber structure.
Right.
Some GCs are self-performing, like a Swinnerton.
Okay.
Some are hiring out somebody else to do the erection or giving it to another one of their subs or
Okay.
trades. The suppliers are, I mean, it's pretty simple. It's actually the way it's been explained to me. You know, it's really a kit of parts. It can be very similar to assembling like a steel frame building with not quite the amount of complexity. There's not the welding and what have you, but they say you don't necessarily need a lot of training, but I would check with your supplier.
Okay.
Yeah.
Just to add to that, there is no code requirement for certified mass timber installers.
Yeah, I will say on some of our earlier projects, the contractors have gotten some guidance from some of the mass timber suppliers for like some consultants that could help them with that. You know, I think though now we've been seeing a lot more larger contractors get experience with mass timber and even starting like their own self-perform groups. So on the large corporate campus that I talked about, that contractor had only done one other mass timber project and ended up self-performing the mass timber, but we had lots of conversations on who would touch the material, just given that you're using like the steel crane to lift in all the steel, but then like, you know, you want to also be lifting in your mass timber panels. And so just lots of conversations that you just need to have really early on to keep the project, be able to keep the mass timber in the project.
Megan, I kind of wanted to just jump in real quickly and add to your very first point that you talked about, the grid integration and manufacturer integration. And what she was getting at is engaging the mass timber manufacturer supplier early is totally to your advantage. There is something called PRG 320, which is the product standard. Within that product standard, it has a very limited number of what we would call basic layups. That's what the product standard publishes. If you as an engineer or architect base your design on that product standard, one of the basic layups, you're going to really limit finding the sweet spot for spans and thicknesses. And just as an example, there's some layups that are 4 1/8 inches thick. They all use the same thickness of lamination. The next step up is 5-ply 6 7/8. If a 4 1/8 doesn't quite work, it would be a huge inefficiency to jump to the full 6 7/8. That's all that's in the product standard. When you go to a particular manufacturer, they have actual product reports, and they will potentially have 15 or 20 different custom layups that they do. And that's the beauty of it. A custom layup could be 4 1/2. 5 inches thick or something like that. And so if your grid would fit great with that and you go to that manufacturer, now you've optimized that, or they can help you set the grid. But if all you're doing is designing with what's in the product standard and sort of oblivious of who the manufacturer is going to be, the chances of you getting a really optimized span to be very cost effective with the CLT, it really limits you to what your layout of your bearing walls and or beams are.
Yeah, that's a great point, Mike. I think we've been seeing that a lot, especially when you're getting into char and when you're asking your mass timber panel to provide the fire rating as well. And so, yeah, we've been seeing on some projects and talking with suppliers to get some custom panel made up, like a 4-ply, which you wouldn't typically be standard, just so that you can have that sacrificial char layer while still getting, you know, your exposed CLT and not having to cover it up and all of that. And yeah, it's really key. And Mike's really right that it's really your floor sandwich. Keeping your floor sandwich as thin as possible is going to keep that volume of lumber down and keep the cost a lot more competitive. And so I guess I didn't mention on that Brentwood Library project, we kind of took the CLT option and then the more traditional concrete over metal deck option through like DD and got that kind of priced. And the mass timber did come out at a slight premium. It wasn't that high. But you know, the architect was able to convince the owner to kind of keep it in the budget. For the other large corporate campus, the mass timber is definitely at a premium. You know, that's definitely not the best example of how to best use mass timber to make it cheap, just because of how custom everything was. And while we typically had a typical 22-foot grid, which, you know, in hindsight, knowing that the manufacturer's typical grid is about 40 feet, or manufacturing capability, we would have rethought that grid had we had that supplier on earlier. But being able to, yeah, just think about those things as early on in design, I think is going to be key. And the more you can replicate that panel, as John was mentioning earlier, the cheaper your system's going to be. So I do really see mass timber taking off in the multifamily residential space, just given how much you're replicating your floor plate as you go up the height, and then with coupled with the tall timber provisions. You know, we're working on a bunch of multifamily residential tall timber towers as we speak, all sitting on concrete podiums. So lots of that in the Bay Area and down in LA as well. So it's definitely becoming more and more common. I do see, let's see, we got a question about acoustic integration. I'm sure, John, you have a lot to talk about this, but I will, the small part I can add as a structural engineer. We have, been talking a lot about acoustics on our projects, and so needing to do even some testing on some of our projects as well. But yeah, there's definitely some consultants out there that specialize and can help you with that. But yeah, paying really careful attention to your details is going to be key. And yeah, John, I'm sure you have a lot more to add on that.
Yeah, I think that's exactly it. And one thing we discovered on a recent project is that wood in general is a pretty decent acoustic material. It performs pretty well is what we're seeing, but it's terrible in low frequency noise. Actually, we had a helicopter adjacent, and the only thing that was really going to stop that kind of vibration was density, right, of a material. So we had to add concrete to make that happen. Not the end of the world, you know, but you just have to understand exactly what the noises that you're trying to inhibit, you know, kind of how they're operating. In that sense, I always think that an acoustic consultant is always a great add to your team anyways. There are some great resources actually on the Woodworks website about acoustics. So I would encourage you to, when you get the PDFs, I got some links to the shared resources page.
And John, I was going to mention that is one of those, we do keep an inventory of, you know, as up to date as possible with all acoustic tests of mass timber assemblies. So if you're looking for something like that in mass timber, that's something you can come to our websites available on there.
One other suggestion I would have in helping you get mass timber into your project is to take your clients to a mass timber building. I think it's really just unlike anything else you've been in, and once you've been in it, you get it. And you know, we'd be happy to show you guys around some of the our construction projects once they get into construction. So definitely hit us up if you're interested in the LA area, or I guess anywhere where we have offices, and I'm sure John would do the same. And yeah, Woodworks is a great connection as well to kind of get you into these like building tours while in construction, or even go visit some of the buildings that have already been constructed.
Yeah, it really does seem to, one, sell people on the idea of using mass timber, and two, was it clearly in my study was something that was identified as being an issue in some areas when there weren't really close examples for people to tour. I think it's going to, as these projects get built, it's going to become more and more available, and I think people are going to really start recognizing it as being a valuable tool to have an example for lots of different reasons.
Yeah, and Woodworks does a great job at that, and the Mass Timber Conference, if you can make it up, well,
Mass
if
Timber
it's ever in
Conference.
person again, getting up there and really just seeing those buildings. But yeah, it's really impressive once you go and see them. Yeah, you definitely understand it once you're there.
Yeah, and this is, just a personal thought. Like, I really enjoyed the Mass Timber Conference when I was there for the couple years ago. And you really do meet a lot of great people, and it's a great energy in the crowd, and you will learn a lot. If you are serious about exploring the mass timber stuff, I would recommend seeing if you could go, maybe not this year, maybe next year, but if you really want to get an accelerated course and experience with kind of what's out there and meet a bunch of really, really great people, both in terms of like products and engineering and architects and what have you, it's a really great event.
What other questions do you guys have, or topics?
Does this reduce the construction documents down to, does it go down? Are you just eliminating construction division or not?
It's not
really?
quite as nice as that.
Okay, well, I'm just wondering, because there's something I'm kind of missing in here when you say there's fewer people at the job site. Does that mean you're, in some ways, you're dealing with fewer construction skill sets? Could that be said, or not necessarily? You still have all the traditional divisions, 50 divisions, but just maybe different, not as linear or something. I'm trying to.
I guess my point on that was more just that it was a small crew to get the mass timber installed.
Okay, to get it in.
I think it would depend on what other, if you have like structural steel beams, for example, you would still have to deal with all the trades, and that's definitely something to consider when putting your project together and working with your structural engineer, because that definitely comes into play. Something else that you were saying I wanted to touch on, and now I'm blanking. You were talking about
the way the construction documents are written.
Oh, yes, thank you. Yeah, so funny thing you say that is we've been definitely getting into more and being asked more on our projects, at least with mass timber, to get into like fabrication of shop drawings.
Yes.
With mass timber, just really showing where they're going to specifically cut the mass timber panels. And yeah, it's been something we've been doing on projects, and we started to explore even go deeper and explore kind of that, the whole talk of like a digital twin and having just really high LOD models, and looking at just some alternate to Revit 3D modeling programs that are more designed for fabrication. And yeah, we'll see how it goes. We'll obviously need our architect counterparts to adopt that as well. But yeah, we're definitely working with an architect that uses CATIA, which, we're actually starting to look at as well as a structural engineer. And just given that, yeah, we're working on a bunch of these mass timber projects. Yeah, it's just interesting. So, honestly, the building departments are going to be so far behind it. Where I work, they still require paper copies and wet signing. I mean, it's a little ridiculous, but the idea would be, the design teams potentially designing these construction models so that you're not having 8 different 3D models out there, and having something a lot more accurate. And I think that'll go a long way, I think, with our industry, as more automation comes online and more information can live in a digital format. Having that information, at least from a structural standpoint of the structure and how things were built, I think will really game change how we consider like reusing existing buildings, which I think is a huge strategy for sustainability. And if you actually know, how the thing was built as an engineer, we can much more easily adapt that to future uses, so that you don't have to tear down that building just because it doesn't meet the current needs of the time. Yeah, so just seeing a lot of shifts in that space, and our industry hasn't really innovated ever. You know, like we still build buildings the same way we have forever. And I think, yeah, the more we can adapt and yeah, the more I think we'll be in a better position. And I do think pre-manufacture is kind of the trend right now. And yeah, a lot of the big tech players are exploring that space and how they can build buildings differently and you really change the construction process and leverage the as much offsite construction as you can to really cut down on cost and construction time. So yeah, it's exciting, exciting time, but yeah, just still a lot of stuff in the works, nothing out there yet.
I'm glad you touched on that, Megan. It's really, there's some really wonderful potential opportunities, you know, because of the technology that we're talking about and pushing technology in terms of the modeling for construction and all that kind of stuff, but also the offsite. Don't forget, it's all prefabricated, right? Old school, right? This the kit of parts that comes to your site. But it is potentially a really great economic engine for, you know, communities outside of cities that don't necessarily have a lot of work to go around. In that sense, I think it's truly a win-win. It's going to keep your construction costs down, and it's also going to engage people who otherwise might not be working. So I mean, it's just really some wonderful, powerful synergies that I think could come out of having more of this stuff in play.
And John, just to add to that, you know, mass timber, that's obviously a prefabricated element. The more things you can do offsite fabricated, the more efficient their job goes, the faster it goes. The quality control is always better when you can build it in a controlled environment instead of out in the weather, freezing cold. But if you're really looking to do mass timber, but you're a little, you know, don't want to get your feet too wet, and you're considering going with a hybrid system where you're using light frame walls, that is getting pretty common. But what I would really encourage you to do then is consider embracing offsite fabrication for your light frame walls as well. So now you're getting more components fabricated offsite, not just the mass timber, but all your walls, your stick frame walls. They come out just like the mass timber on a truck. You fly them into place. That's how you really realize the true speed of construction.
Yeah, and I see that really coming into play. You see it in the developments just on the prefabrication side, even outside of mass timber, both residential, affordable housing, and hotels. I think that's going to be, when everything kind of gets back to trued up and no COVID, I think we'll see greater impact there.
I agree.
What else do you guys have?
We're getting near the end of time here, but one maybe a question I have to try and wrap things up is what can we do to help catalyze all of this? Beyond the obvious, let's go work on some of these projects. But one thing that comes to mind is, you know, you mentioned cost, and you've got a few clients that were willing to go beyond that. Perhaps you shared with them a life cycle analysis or you know, the amount of carbon you'd be saving, and they're able to see that that'll actually help save in the long run. Not just, you know, both economically and for the benefit of the people in the buildings, those types of things. But one of the things that's struck me is through advocacy, even if we're not lucky enough to work on some of these projects, but I saw the County of Marin actually adopted a sort of REACH code related to embodied carbon of concrete. So I'd imagine that in turn makes people look at wood twice, you know, maybe to avoid being penalized, or are there other types of codes and policies that you guys have come across that are out there that haven't been adopted, or even outside the US, that seem they might help just, you know, light this, get it going and faster?
Yeah, I can jump in there. That's a great segue. Yeah, well, so code-wise, yeah, I think the low carbon concrete code is kind of the first. It's the first in the U.S. We have been, or I was part of a little concrete LCA study that did kind of help set those benchmarks for the Bay Area for the GWP limits. And we've been seeing other cities around the country want to replicate our study so that they can look at potentially adopting the same code, but with different limits that are applicable to their regions. One thing that you guys should be aware of within at least the structural engineering profession is an initiative that was or a program that was recently launched, SE 2050. So that is kind of the structural engineers' take on getting to net zero embodied carbon by 2050. And it just launched by the Structural Engineering Institute. And we have over 20 firms committed, structural engineering firms committed to doing their part in getting to net zero. And mass timber, I think, is a big part of that, as well as low carbon concrete. But yeah, I think something like that. And, we're really hoping to, get at least 50 to 60 firms committed by the end of the year. And we have some pretty big names already committed, which is exciting. So I do think you're going to start to see, at least from the structural engineering perspective, and hopefully, spurred on also by our architect counterparts and building owners that are really interested in the whole topic of reducing embodied carbon, because there's just a lot of strategies we can do, and mass timber is a big part of it as well. And yeah, so at least I see that. Yeah, we'll see if we get any more type codified systems yet. I don't know if there'll ever be a carbon tax or whatnot, but
yeah, probably not at this point. But I do think that also touches on the other side. Like, what is our governmental agency responsibility for helping this along? And I do see, in terms of your advocacy that you mentioned, Robert, we needed to incentivize mass timber, right? There need to be tax breaks or other kinds of offsets for people who want to build this stuff to make it more appealing and to help balance their checkbook. So, and I don't think it would take that much. And I don't know if there's anything even in the works. I mean, Jennifer and Mike, you might actually know a little bit more about, government action in play.
Yeah, so I think at the federal level, they're still trying to decide exactly how you account for carbon. They want to make sure it's done in a way that doesn't penalize one material over another. It needs to be a carbon, not a wood first. In Canada, they were able to do sort of a wood first initiative. In the US, we don't want to make it about material, we want to make it about the carbon impact. So there's still a lot of negotiations as to how to do that. There are a number of companies now, though, that are just starting to evolve that I was actually just on a call with them recently. Arias Earth, I think is the name of it. And basically what they are going to do is, if a developer is interested in going with mass timber instead of a steel or concrete building, it has to be a substitution situation. They will, you run an LCA on it, and then for the amount of carbon that's in there, those carbon credits, they will actually then go and sell those. So for a builder, you could then get a rebate basically on your building, $20 to $50, I think, per ton of carbon is what they're looking at, and then they go and sell it on like a private carbon market. So it was an interesting structure. So I think some privately are looking to do this and get off the ground, as opposed to, as the governments are starting catching up. There is another piece that's just put out by Think Wood that I can look for the link on, and John, I can send it to you, that they look at all the policies internationally, so you can get a sense of what other countries are doing. So if you're interested in kind of just knowing what's happening out there, if there's something you wanted to get involved in from an advocacy perspective, you could. We don't get involved in advocacy because we can't lobby because of the way we get our funding, but we're happy to share with you what other places have done if there's anything you ever wanted to get involved in. So John, I can follow up with you on that once I have a link to that document.
Yeah, I'd be happy to see that and we can share.
I think that's a great way to close. Will Wright has been a terrific resource in helping us advocate. So if anyone on this call is interested in doing that, there's Will. Feel free to reach out to anyone here, and especially Will, I think, has his finger on the pulse with city councils and you name it. And to echo what Jennifer just said, I just want to reiterate that it's great to advocate at the highest level possible. That would have the greatest impact. But in the absence of that, a lot of the local jurisdictions, like the Marin County, it sounded like Megan was part of that, which is so awesome. And then other people reach out to her. It's actually the story of our green code. We had maybe over a dozen different localities adopt pretty much various versions of LEED or the Green Point rating system. And then, the next code cycle, we saw California do something no other state had done and adopt its own green code. And it wasn't any one of those exact localities, terms. They had to come up with all their own. But it's clear that there is an influence and a link, and it goes up and down. So wherever you're able to advocate, and for I think most of us, that's at the local level, that's really what we should be doing if we're able to. So with that, Will, I don't know if there are any
Well said,
closing
Robert.
comments.
Well, no, I just want to say thank you to everyone. Thank you, Robert, and Zenaida, and Megan, and John for bringing us all together tonight. And we're here. So AIA Los Angeles, reach out to me if you need anything. And we look forward to further connecting.